Hello everyone, this is Priyanka Gopinath. Let us continue reviewing the second part of the chapter, Matter in Our Surroundings. We know that water can exist in all three states of matter, namely solid as ice, liquid as water, and gas as water vapor. But how do they exist in different forms? There are two main reasons. Number one, temperature, and number two, pressure. Let us look at them in detail. The effect of change of temperature. Increase in temperature is directly proportional to kinetic energy. The energy supplied by the heat breaks the intermolecular force of attraction. Hence, the particles leave their position and start to move freely. This movement of the particles leads to the change in the state of matter. That brings us to what melting points and boiling points are. The temperature at which solids melt down to form liquids at atmospheric pressure is called as the melting point of the solid, and the temperature at which liquid starts boiling to form gas at atmospheric pressure is known as its boiling point. We need to note that the higher the melting point is, the higher the intermolecular force of attraction between the particles, which makes complete sense because when the intermolecular bonds are very strong, we need to apply more energy to break these bonds. The melting point of ice is 273.16 Kelvin, which is approximately 0 degrees Celsius, and the boiling point of water is 373 degrees Kelvin, which is approximately 100 degrees Celsius. We also need to remember this value, that is 0 degrees Celsius is equal to 273 Kelvin. They often ask us to change the values given in Celsius into Kelvin and Kelvin into Celsius. So knowing this value will be of high use during your examinations. There are two main terms you will come across when we talk about change in state of matter. Number one, latent heat of fusion. The amount of heat energy that is required to change 1 kg of solid into a liquid at atmospheric pressure at its melting point. It basically refers to the amount of heat that is used to break the intermolecular force of attraction. As you can see in the graph, there is a point where the heat is not increasing and it's stagnant. It doesn't mean there is no heat supplied or used. It means that the heat is used to break the bonds so that solid can be converted into liquid. Now the second term you'll come across is called the latent heat of vaporization. The amount of heat energy that is required to change 1 kg of a liquid into a gas at atmospheric pressure at its boiling point. It is basically the same as latent heat of fusion, except that this is specifically for liquids converting into gases. The effect of change of pressure. Gases can directly change into liquids by applying pressure and reducing the temperature. The lack of space for the particles makes them settle down together as a single mass and have a fixed position, as you can see in this image. The space given to this compound is reduced and you can see the particles becoming compressed and taking very little space at the end of the experiment. Solid carbon dioxide directly changes into gaseous form even if the pressure of one atmosphere changes. This is the reason why solid carbon dioxide is also called as dry ice. Interconversion of states of matter. We have come across the same diagram ever since grade 3 and this is not a new topic to us. Solids change into liquids through the process of fusion. Liquid changes into gas through the process of vaporization. Gas changes into solids and solids changes into gas through the same process of sublimation. Gases changes into liquid through the process of condensation and liquids changes into solids in the process of solidification. That's it. Evaporation. We have come across this term again ever since 3rd grade. Now let us look at few different aspects of this phenomenon. Factors affecting evaporation. Number 1. An increase in surface area. Evaporation is a surface phenomenon. We shall look at what a surface phenomenon is in a few minutes, but when the particles are exposed more, the rate of evaporation increases. Number 2, an increase in temperature. Increase in temperature refers to an increase in the heat supply. This heat increases the kinetic energy of the particles and hence these particles enter into a vapor state. Number 3, a decrease in humidity. Humidity refers to the water content in the atmosphere. And obviously, when there is enough water in the atmosphere, it will not collect more water. Thus, the rate of evaporation decreases when humidity increases. And number 4, an increase in wind speed. If the speed of wind increases, the particles of water move away along with the wind, which decreases the amount of water content in the surroundings. Evaporation has a special property. It gives a cooling effect as it happens. During evaporation, the particles of liquid absorb energy and latent energy of vaporization from the surroundings to convert into gaseous state. This absorption of heat from the surroundings makes the surroundings cold. Now let us look at what surface phenomenon is and bulk phenomenon is through a table of comparison. In a bulk phenomenon, all the particles in the bulk are affected, whereas in a surface phenomenon, only a particular layer of particles in the entire bulk are affected. In a bulk phenomenon, the heat energy is always supplied from the bottom of the liquid, whereas in a surface phenomenon, the direction of heat is never from the bottom. That is why in a bulk phenomenon, all the particles are affected because the heat is supplied common to all the particles, whereas in surface phenomenon, the direction of heat can be from either of the sides or from the top or at any angle, and that is why only the layer pertaining to that angle gets affected, but not the other parts of the entire compound. All particles in a bulk phenomenon have enough energy to break the intermolecular force of attraction, but in surface phenomenon only a small fraction of particles at the surface gain enough energy to break the intermolecular forces between the particles. An example of bulk phenomenon is boiling, whereas an example for surface phenomenon is evaporation. Thank you. We hope you enjoyed this session of Matter in Our Surroundings with me. Please like and share this video and subscribe to our channel if you found this video informative. Thank you.